And hello everyone, welcome back to another nim tutorial. In this tutorial we'll be continuing with the OS module in nim. So let's start with import std/os to get all of the features that the OS module provides us. So let's say you want to set an environment variable. Now for those of you who don't know, an environment variable is something such as $home. This is an environment variable. It points to this directory. I think a person can echo it out. Yeah, as you can see, it points to this directory. That is an environment variable. You have a bunch of these such as path. This is also an environment variable. Well, it's a big one, so I'm not going to print it out, but you get the idea. So it's basically a variable, just like a nim, but you can use it inside of your shell. So inside of your terminal. Now you can set your own environment variables in nim, such as put env, and then you give the environment variable name such as node env. This will usually be like your Node.js environment variable. And then whatever value you want to put in it, such as test. Then to get the env, you can go echo get env and node env. And this will get the env and print it out for us. So if we compile this, we'll actually get test because that's what we saved in node env. However, note that when we echo out $node _env, we don't actually receive a value. This is because once the nim program shuts down, this node env variable is also removed. Because when you run a new nim program, it basically works in its own shell. You can also delete in env. So here we can actually remove this, and we can say del env, and this will delete the environment variable. And then we can also check if it exists by going exists env. Now this will of course be true if this environment variable exists, but it won't because we deleted there. So if we run this, we get test and then false. But if we never delete that environment variable, we'll get test and then true, because then the environment variable does exist. You can also execute shell commands. So the type of commands I would put in here. It is generally frowned upon to do so, however, so take note of that, because usually when you write a program, people don't really like it when you directly interact with their shell. So if I go exec shell command, and we say dir as an example. If you run this, there you go. So basically if I were to say dir here, we'll get the same output. Now again, this isn't really something that people like because it can have destructive properties such as sudo rm-rf/. Don't execute this because this will delete your entire system. But this command here, very dangerous, so people don't like it when you directly execute shell commands. Instead, it's better to install a library that will run shell commands for you, because then you don't have to directly interact with the shell, and that also keeps other people happy. But as an example, let's say rm lols.txt. If you're on Windows, rm might not work. I don't remember, I think it's del on Windows, but I don't remember how to do that on Windows, since this is system specific. So if you're on Linux or Mac, your commands you put in here might be a little bit different than on Windows. That's why I use dir as an example, because dir works both on Windows and Linux. Anyhow, so when I run that, and here it actually asks me if I want to do it because it is currently write protected because of our last tutorial where we changed up a bunch of things. I'm just going to press enter, and now do we still have it? No, because I didn't say yes. But what they could have done is they could have said sudo and say this application needs super user privileges and you need to enter your password. This is a very easy way to make a very dangerous program. So generally don't use this unless you really have to and you have no choice. But in nim there's always a workaround, so it's always best to avoid it. We also have echo get current process ID. So this will get the current process ID of our application. So if we were to run this, we'll get 124688, and it will change every time we run it because we will have a different process ID given to us when we run the program. You also have is valid file name, and this will check if a file name is valid, such as my file and my file. So this one will be false and this one will be true for obvious reasons. So if we go here, it will say false if I say touch my file like this. We will get the file here, but you'll also notice it's in quotes because luckily Linux is smart enough to kind of fix this for you when you do it in here. But this here is generally frowned upon. That should not be in a file name. A useful function you can have is sleep, such as sleep 1000. This means sleep the program or wait the program for 1 second. So if I say echo start and then I say echo end and I run this, we get start and end. But you'll notice there's a little wait every time. So let's actually make it a little bit longer so the wait is easier to see. So run that, we get start. Now we have to wait 10 seconds. Once 10 seconds is over, end will execute. So sleep is an easy and quick way to just say stop and wait. There we go. We can also get all of the environment variables. So echo, so for env and its value in env pairs. So this will get all of the environment variables in pairs of the env itself and its value. And we can just echo env colon and then its value. And this will of course get all of the environment variables and their values. Now there's of course a ton here. But in our case, as you can see, there is environment variable there, there's one there, there's one there. So you basically get each and every one and you can work with them as you need it. I have a ton of environment variables, but as you can see, it's pretty easy to get them if you ever need to work with them. Here we have a for path in, and in here we can actually put a path that we want, dot parent ders. And just echo path. Now the idea here is that it will print out every path until it gets to the root directory. So if I go, and let's go pwd, I copy that, paste that there, run that, then here you see it prints out every parent directory until it finally gets to the root directory of your system. So if I go ls/, this is my most root directory, so all of my system files and stuff goes here. So it basically makes its way back to the root directory from wherever you put in here. You can also do it the opposite way by just going from root and making that true. So if we were to then run this, it will do it from the other way around, so it'll start at root and make its way up to this directory here. For item in walk_dir, and let's actually just use this. So what's going to happen is we're going to walk this directory, meaning we're going to get all the items in this directory. Let's echo out item and see what we get. So if we run this, we get the kind, such as PC file. It can also be PC dir, PC link to file, which is just a link, a symbolic link to a file, and PC link to dir, which is a path that refers to a symbolic link to a directory. But for the most part, you just have to concern yourself with PC file and PC dir, where PC dir is a directory or a folder, and PC file is a file. So if we were to go like this, you'll notice we have PC file, and here's the path to lols.txt. This is a directory, it's nim/test, also a directory, tester, file, main.nim, and so on. So it allows you to get all of the files in the directory that you put in here, and then also get what type of file it is. So is it a link, is it a directory, is it a file, and so on. If you want to do it recursively, meaning you want to get the files inside of the folders as well, then you can also do rec, which basically means walk the directory but also recursively. So in this case, if you go like this, you wouldn't get the file type anymore, but we do get all of the files inside. So here is tester, and in this case we just said tester. We didn't get the txt file inside of tester. So this will allow you to recursively walk through each and every directory. However, it does not return the type of file. Another thing we can do is let's go. So here's my nim directory. It has a folder and thumbnails file, and there's all the tutorials inside of it. Now let's say I want to walk this directory. So let's copy this. We paste it in here. And in here, instead of saying walk dir, we say walk files. And now what we can do is we can say /star.mp4. This means walk through all of the files, but only get the mp4 files. So if I were to run this, we'll get all of the mp4 files. But if I were to just grep-i xcf, you'll notice we didn't have any xcf file here. But I could go xcf here, and now we'll only get the xcf files, which is my thumbnail files. If I run that, you'll see there's an xcf, and that doesn't get the video files because they end in .mp4. So you can use a little bit of regex to get specific files that you want. However, this doesn't support full regex. What you should instead use is walk pattern. And this supports you entering a pattern. So here I could say star.xcf. If we run that, that would still work. But I could also go here /a star, or there wouldn't be actually, let's go 1 star. Run that, and we get all of them that starts with a 1, and so on. So this allows you to really put a pattern in here to search for files in a directory or to walk it. And that is all I'm going to cover for the OS module in nim. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next nim tutorial.